Hello students, good afternoon. Welcome to one more amazing session from Infinity Learn. मैं हूं Suresh, Faculty of Chemistry. Today we are going to discuss about chemistry, most important topic from the organic chemistry, that is alkenes. I want to say about alkenes, once you are good at alkenes, you can convert anything into anything. So we can say 25%. Hello students, good afternoon. Welcome to one more amazing session. 25% of organic chemistry you are going to be so confident in it. Okay, so one minute. అది ఇందాక అనలిటిక్స్ ఉంటుంది కదా, అది పెట్టండి.
మీకు ఇది చాట్ బాక్స్ కనిపించదు అనేసి అది పెట్టండి.
ఇదే బెటర్. ఓకే. So before going for the session about the alkenes, I just want to show you something for you to motivate. Double your score in the proven result with Infinity Learn by Sri Chaitanya. Here I just want to show 4 students here. Ashrita, Akhil Verma, Hemadyuti and Satyanarayan. You can see Ashrita, you can see the score between 2023 and 2024. In 2023, Ashrita got 310 marks and 2024 661 marks. Similarly, you can see Hemadyuti and 310 marks in 2023 and 652 marks in 2024. You can see the score is almost doubled, is more than double sometimes. You can see Akhil Verma just 313 marks in 2023 and 658 in 2024, and there is a 345 marks increment. And also you can see 330 marks in 2023 for Satyanarayan, and he got 650 marks in 2024. There is a 320 marks in the increment. So you can see NEET 2023 and 2025. At 2024 there is a mostly double the score. Not only these 4 students, but also with Infinity Learn, the students, hundreds of students got the score like this. And you will be the next. Are you ready? Because you are with Infinity Learn and you can ace your pace in the NEET examination preparation. Bacho, and just I want to say, crack your NEET examination and reserve your medical seat in a premium medical college. For that, you attend the classes regularly and like our sessions and share with your friends. इन लोगों को भी फायदा होना चाहिए, and subscribe to Infinity Learn NEET YouTube channel. And also SEO test prep with Infinity Learn. In that Infinity Learn Meta app, you have live classes, mock tests, create your own test, and 24/7 doubt resolutions. And you can see Infinity Learn is there on the social media also, Instagram and YouTube. You are right now in the YouTube, and also we have Infinity Learn Telegram channel. In this Infinity Learn Telegram channel, link is there in the description box. You can click it and you can enroll it. What you are going to learn from this. So in this Telegram channel, you have daily quizzes, session schedules and session notes, session assignments and many more. You can have an awesome journey with Infinity Learn Telegram channel. So whenever you take a mobile, you just use the time for the other reasons, but it is good for your academic reasons. And also I just want to say, आजकल आर्टिफिशियल इंटेलिजेंस इसका हलचल ज़्यादा चल रहा है, लाइक चैट जीपीटी कैसे है. नाउ पाथवे टू एकेडमिक सक्सेस, इन्फिनिटी लर्न जर्नी विथ AI enabled academic program is given by Infinity Learn. Hi, some name Kim Jong-un. You're from hi. And many students are here attending the classes on a regular basis, and many students I can find those students who are attending abroad also. Okay, anyways, AI enabled academic program, India's first AI enabled academic program is given by Infinity Learn, which includes goal setting, set your academic and skill enhancement goals. And also you will be having awesome lectures with well experienced faculties, and you will be having live classes with the faculties, and you can see test and paper analysis. Whenever you write some test, it is analyzed by AI tools and given the accurate prediction of the where you are good, where you need to improve, you know. And also you can have self-study and package and revisions, conceptual videos, mock test and practice test, and flashcards सब मिलेगा. एंड फ्लैश कार्ड्स अच्छे तरफ आपका काम आ जाएगा, क्योंकि ये जो भी आप पढ़ाई कर रहे हैं ना, तुरंत आप रिवाइज करने का फ्लैश कार्ड्स इस्तेमाल कर सकते हैं बेटा. एंड ऑल्सो यू कैन सी एनी डाउट एट एनी टाइम एट एनी प्लेस, योर डाउट इज सिंपली a click away. That is doubt resolution 24/7. That is AI powered doubt resolution is given. And why late? The QR code, you just scan it and you can use your preparation with NEET examination. Okay, so चलता. और एक चीज है, India's largest scholarship examination, score examination. This score examination helps you. Why it is India's largest examination? Because this score examination is India's largest because it gives you 1 crore rupees worth of scholarships. Yes, it is true. In India, Infinity Lane is offering that. And also study setup and laptop भी है, it is also very important thing. Educational allowances भी है and up to 100% scholarships है. Why late? Description box, that link is available and you click it and you just yes and score examination link, you click it and enroll and enjoy all the facilities of the score examination. And all the best and good luck. And also last but not least, NEET 2025 All India Test Series Pack. Why this is that important? You are all good students and sincere students. You are working so hard in NEET examination race. So for that, how you are preparing, that has to be properly assessed. For that, appropriate assessment is given by this test series pack. In that you will be having 27 AITS test. उसमें आपको मिलेगा 13 unit test and 4 part test and 10 grant test. It is based on complete NEET pattern and 20 online NEET full syllabus mock test and 25 NEET topic wise PYQs. Hi Ram, hi, how are you after a long time? 3 physics chemistry books are available along with video solutions on app. Good afternoon. And detailed solutions and performance reports for every test and your performance is benchmarked with Sri Chaitanya. इतना सारे facilities कौन देगा? Infinity Lane is giving to you. Ram, good afternoon. And it cost is 5,999 था. अभी तो स्टूडेंट्स का रिक्वेस्ट बढ़ गया, सो दैट इन्फिनिटी लेन इज गिवन ए वेरी लिमिटेड टाइम ऑफर टू 2,999 एंड दिस इज अवेलेबल व्हेन यू अप्लाई यू 250 ऑफ कूपन कोड, तभी आपको 50% डिस्काउंट ऑटोमेटिकली मिलेगा. हाय कनिष्का हाय एंड प्लीज डोंट स्पैम इन द क्लास. So well done. We are going to start the details about these alkenes, right? In this alkenes, what we are going to learn? I want to take this alkenes presentation in such a way that where you are going to exactly get a question, right? So get ready for that. So talking about alkenes, alkenes are unsaturated hydrocarbons. Their molecular formula is CnH2n, that's it. In that we need to have just preparation and properties. In that preparation you are going to have elimination process. So I just want to give you the elimination, preparation of alkenes by elimination. So how do you prepare alkene? Two major methods are there. So in that elimination you are going to remove, hi Ram, you are going to take 2 carbon atoms. In that one is a leaving group and the other carbon atom what leaving group is bearing is called as, the carbon with the leaving group is called as alpha carbon. इसका बगल वाला जो है ना, that is called beta carbon atom and you are going to leave the beta hydrogen. So this is what you say beta elimination. When you remove this and this, now you are going to get a double bond between these 2 carbon atoms, so that an alkene is formed. This formation of an alkene, you have 2 types of reactions. One is dehydration of alcohol, another one is dehydrohalogenation of alkyl halide. So if you know it, you can do various kinds of reactions. So in this beta elimination, you have two methods. One is dehydrohalogenation and dehydration. So let us discuss mostly about the dehydrohalogenation and dehydration, and we will do some examples, and we are going to discuss about some multiple choice questions based on that. Eventually we will go into the electrophilic addition reactions, so that in a short period of time, in one shot, total alkenes are going to be discussed. Is that fine? So in this dehydrohalogenation, carbon to carbon bond and a hydrogen and a X stands for halogen. Halogen is going to be here chlorine or bromine or iodine. When you use a strong base, the base can be potassium hydroxide or sodium hydroxide in the presence of alcohol, and you heat it. Elimination reactions are endothermic reactions. Elimination reactions are endothermic reactions, and it is going to remove this halogen and this hydrogen. Don't focus on the total details about the mechanism. We use this mechanism and we will get it out of rule and will give the product. So when you do this, you are going to get an alkene like this. So halogen and hydrogen is removed, that is called dehydrohalogenation, this reaction. And this dehydrohalogenation reaction, what are the major areas where you are going to get a question? So reactivity, alkyl iodide is more reactive than alkyl bromide is more reactive than alkyl chloride is more reactive. That is the first version. And for this reactivity, tertiary alkyl halide is more reactive than secondary alkyl halide is more reactive than primary alkyl halide. So in my session today, I just want to give you more opportunity to understand where a question can come from this particular equation. I don't want to unnecessarily go into the details about each and every mechanism. If you go into that one short revision, you can't do it. And one more important parameter I just want to say, rate of elimination reaction is directly proportional to the stability of alkene. Who is going to stabilize this alkene? And this can be stabilized, alkene is stabilized by hyperconjugation. And one more important thing is a Sagejev rule is formed. Sagejev rule. What is this Sagejev rule? So during beta elimination, the product formed is going to be the most substituted alkane. So I just want to say here an example. If you want to say here a chlorine, when you potassium hydroxide is added and you heat it, you are going to get this is one product and this is going to be another product. Among these two, this is the major product. Why this is the major product and this is the major product? Because this follows Sagejev rule. The more substituted alkene is the major product. Hope you are understanding. Clear, Ram? And otherwise, I just want to use the same alkene. I want to use potassium tertiary butoxide. It is a bulky base. Whenever bulky base is used, you are going to get the reverse product. And I want to say the product you are going to get like this as well as like this. So if that is the case, so I just want to write the product here. This is the major product. Why this is the major product? This is governed by Sagejev and this is governed by Hoffman. And here it is small trick to you guys. When to form Sagejev product, when to form Hoffman product. In most of the cases, Sagejev is only formed. Hoffman is formed in the case where bulky base is coming. when the size of the base is bulky, Hoffman product is formed. And also you can see the Hoffman product in the case of the leaving group is a poor leaving group. Got it? Poor leaving group. That is the important parameter. This is about the dehydrohalogenation. Let's talk about dehydration of alcohol. In the dehydration of alcohol, you can see CH3, CH2, OH. What happens if it is reacted with H2SO4 and heat it? So, for the dehydration of alcohol, you are going to see the formation of a cation in general. So, this CH3, CH2, OH, the OH is a poor leaving group. So, that once it is protonated, it is going to be protonated. So, it gives you CH3 and CH2 and OH2 plus. So, this OH2 plus, ELISA OH2 plus is going to be a very good leaving group. Okay, ELISA, any doubt? So, this can be released as a water molecule. Water molecule is lost, therefore, it is called as a dehydration, right? So, once the water molecule is lost, you are going to get CH3 and CH2. Carbocation is formed. The main important note about this is a carbocation. Once this carbocation is lost, so this is your beta carbon proton is lost to gives rise CH2 double bond CH2. So, if I ask a question, I hope you can give the answer. Now, let us see here carbocation intermediate formed. So, carbocation intermediate formed, it has the tendency to rearrange itself. Therefore, if chance is there, you are going to get a rearranged product. Rearranged product. So, based on this, you may have a question from the NEET examination. Elias and Ram, can you give answer for the question? I just want to say, hi Kim. CH3, CH3, CH3 and CH and CH3 OH. What happen if it is heated along with a proton? Give me the IUPAC name of the product that you are going to expect it. In one shot, I want to cover everything. Make it fast, make it fast. So many things I want to give you. Elias, a question is given. Gear up for your NEET success program. Enroll your NEET test series. Link is given in the chat box itself. You all click it once and you can enjoy it. Okay. What is the answer for this question? Let us write the mechanism for this. So, what happened? The lone pair of electron present on the oxygen of the alcoholic group is going to be taken into the account. So, that CH3, CH and OH2 plus, and it is going to be a better leaving group. So, let it, hi Ram, you tell me the product here, and this OH2 is lost as water molecule. Now, you are going to get a carbocation. Once you got a carbocation, it is going to be CH3, CH3 and CH3 and CH plus and CH2. This is a secondary carbocation. You know, this is a secondary carbocation. This secondary carbocation is less stable as compared to tertiary carbocation. You know? So, what happened? This methyl group from here, it is going to be shifted from here to gives rise a corresponding tertiary carbocation. This corresponding tertiary carbocation gives you, this is what you say 1,2 methyl shift, 1,2 methyl shift. It gives you CH3 and CH3 and CH and CH3. Now, this is going to be a proton is lost. So, it is a beta carbon. Once the proton is lost, you are going to get a stable alkene like this, a stable alkene like this. Understand? Got it? Clear? So you are going to expect a question, the most stable alkene is the product. Like this you can say a couple of questions like this. You check the stability of the alkene. Okay, OH is given. If you heat it, water molecule is eliminated from the OH here, hydrogen here, you can remove here. So a conjugation is formed. So this is the probable product of the alkene. Simply remove H plus from one carbon atom, OH from its adjacent carbon atom if there is no rearrangement. So like this, one more question I just want to give you, and combination of these structures will be given. Combination of structures will be given. So what is the product, you tell me. Here and here you are going to get the same product. Kyunki if it lose a proton here, you are going to get another product like this, but this is the major product. Kyunki this is more stable as compared to this. Abhinav, how are you? How are you, beta? How are you? Right. So Uttam is not there in today's class. Okay, this is about the preparation of alkene. और एक चीज है controlled hydrogenation. Controlled hydrogenation of alkynes. Controlled hydrogenation of alkyne. Arre, don't feel bad. I always bless you. You are one of my best students on the YouTube channel. You will definitely do the best. है ना? No worries. Don't worry. अब अभी तक जो पढ़ाई किया, अच्छा तरफ पढ़ाई किया, आप कल एग्जामिनेशन अच्छा तरफ लिखने वाले हो. मैं आपको भरोसा दे रहा हूँ. कोई प्रॉब्लम नहीं बेटा. अभिनव, इसका नाम अननोन लिखा हुआ, but I can say his name is Abhinav. That much connectivity we have. So in this YouTube platform, students are more connected. Once you attended the classes with me on a regular basis, this connect automatically is going to be developed. Hey, na? Uttam, sorry, Abhinav. Chalta? Ha, yes, of course. Ram is also, yes. Thank you very much. Ram is also my student here. So how you are doing, Ram? Now, what is this uncontrolled hydrogenation? Let me talk about R, C triple bond, C R dash, okay. When it is treated with H2 and you can use nickel or platinum or palladium, you are going to get uncontrolled one, RCH2 and CH2 and R dash, alkene, you got it. So we are about to prepare alkene, right? So this is an alkyne. So मैं क्या करना चाहता हूँ इसको पकड़ के? Two things I want to use. I can use palladium in the presence of barium sulfate and इसका हाइड्रोजन ऐड करके क्विनोलिन सॉल्वेंट इस्तेमाल करना. और दूसरा मेथड भी है. Carefully you see how crystal clearly the presentation is given. If you use lithium or sodium metal in the presence of liquid ammonia, तभी आपको मिलेगा R, C double bond, Cr. So it is going to be anti-addition. So trans-alkene मिलेगा. And here you are going to get R, C double bond, Cr dash and H and H, cis alkene मिलेगा. So it is a syn addition, this is an anti addition, and this is called uncontrolled hydrogenation. This is called uncontrolled hydrogenation, and this is called controlled hydrogenation. That's the difference. Here PDBSO4 quinoline, this is called as a Lindlar's catalyst. This is what is a Lindlar's catalyst, and this is what is a Birch reduction. Actually, the Birch reduction is not there in the NCERT terminology, it is, but reaction is there. And let us talk about, so we have three major methods. One is dehydrohalogenation, another one is dehydration, and controlled hydrogenation. These are the three major reactions that you need to know as far as the preparation of alkene is concerned. अगर फिलहाल कुछ डाउट है ना तो आप पूछ सकते हैं. Any doubt बच्चों? So प्रॉपर्टी शुरू कर लेंगे. रैम, एलियास. सो बी एक्टिव इन द चैट बॉक्स. आप जितना डाउट पूछेगा चैट बॉक्स में हम उतना कॉन्फिडेंस बढ़ा देंगे. Now reactions of alkenes. Reactions of alkenes, मान लो you have two types of reactions. One is electrophilic addition reactions, another one is oxidation reactions. Mind it, in one session, in 1 hour, I want to revise all the reactions, mind it. Okay. So let us talk about electrophilic addition reactions. So addition of Br2 CCl4. CCl4 is actually a solvent. So in this case, carefully you see, this is your alkene. Whenever Br is added, the alkene is going to form a cyclobrominium ion क्योंकि positive charge and negative charge. So Br minus is lost. So non-classical carbocation cyclobrominium ion is formed above. So what is this cyclobrominium ion? You can see this is actually non-classical carbocation. So this is cyclobrominium ion. So that what happened? So formation of the cyclobrominium ion is a rate determining step. In this rate determining step, Br minus is going to attack from the back side. So it is called as anti-addition. It is going to be anti-addition. So it is said to be the product is obtained like this. Br here and Br here. That is anti-addition. So many things you need to know. So many things you need to know. What are the things? Look at here. Red color of the bromine is decolorized. It's a test for alkene. It's a test for alkene. And it is a stereo specific. Stereo selective. So what does that mean? I have a simple trick. ATM. Anti-addition to transalkene gives a meso product. So transalkene CH3, C double bond, CCH3. This is an transalkene. And CAR, cis alkene on anti-addition gives a racemic mixture. So it was a trans. And let us take about the cis. This is your cis. Now when you add this Br2 CCl4 in the medical entrance examination, this kind of application will be given. I don't want to propose any mechanism, I just want to give. Trans gives meso product ATM, so that CH3 and Br, and it is a Br. This is your meso product. This is your meso product. Whereas you are going to get a racemic mixture in this case. Br over here and Br over here. So here a chiral carbon atom is seen, here chiral carbon atom is seen, therefore it is going to be a racemic mixture. So ATM car, you all just memorize this: anti addition to transalkene gives meso product, and cis alkene on anti addition gives rise a racemic mixture. So like that, one slide itself can give you the total picture about this. Hope you understand. And it is a test for alkene. It is a test for alkene. Clear? So bacho, right, that's great. Abhinav, Ram, Kanishka, okay, Elias, okay, you are preparing for pre-boards, don't darna mat beta. Let's talk about addition of HBr. Addition of HBr. Addition of HBr. So when alkene is taken, if HBr or any unsymmetrical reagent is added, it should follow Markovnikov rule. What is a Markovnikov rule? So let's talk about CH3, C double bond, CH double bond, CH2. When HBr is added, okay, so negative part of the reagent attaches to the carbon of double bond which bears the less number of hydrogens. This is called as Markovnikov rule. So it is a Markovnikov rule. So according to Markovnikov rule, the product is going to be CH3 and CHBr and CH3. So this is your Markovnikov product. In this Markovnikov product, if the carbocation is rearranging, you don't follow Markovnikov rule, rather you have to check the carbocation rearrangement. That's very, very, very important. So what Markovnikov says? Negative part of the reagent attaches to the carbon of double bond which bears the less number of hydrogen atoms, that is called as a Markovnikov rule. If you use CH3, CH double bond CH2, when you add HBr in the presence of peroxide, you are going to get Abhinav CH3, CH2 and CH2Br. So that is called anti-Markovnikov addition. So this is called anti-Markovnikov addition, or this is called a peroxide effect. This is what you say, peroxide effect. It is also called as a Karash effect और एक important dangerous point है इसका. Can you guess? Can somebody guess what is the dangerous point in that? Can you guess what is the dangerous effect? Peroxide effect. This peroxide effect is observed only with HBr. So that is the red mark, red card. I just want to say, you can just use this slide to understand what is HBr. है ना? Any doubt? Bacho, can somebody give me the addition product of the given structure? Given structure. One question will do it. One question will do it. If HBr is added, क्या होगा? Product कैसे होगा? You all open a pen and paper and follow this question like this. So in our session today, we are revising the reactions, we are learning the reactions. revising the reactions, and also we are working with the examples, the most updated examples. So do it, bacho. I am waiting for your answer. What is the IUPAC name of the product? Jaldi dena. Jaldi, waiting for you. Abhinav, Ram, Kanishka, Elias, give the answer. Give the answer. So मैकेनिज्म बनना पहले. हाँ, मैं मैकेनिज्म देने का तैयार हूँ. सो पहले ये जो आल्कीन है ना, आराम से कर लो. ओके, सो मान लो ये CH2 है ना, ये HBr प्रेजेंट है, H प्लस दे देते हैं. पिछले जो रिएक्शन है ना, ये वाला इलेक्ट्रोफिलिक एडिशन रिएक्शन, इलेक्ट्रोफिलिक एडिशन रिएक्शन, ये रिएक्शन जो है ना, फ्री रेडिकल एडिशन रिएक्शन, फ्री रेडिकल एडिशन रिएक्शन. ठीक है. हाँ, उसमें इलेक्ट्रोफिलिक एडिशन रिएक्शन क्या करूँ मैं? You are going to add a proton over here, so it become a CH3, so that a कार्बोकैटायन बन गया, so that ये जो बॉन्ड है रिंग एक्सपेंशन करता है, वैगनर रीअरेंजमेंट, so that it is going to give you बॉन्ड यहाँ था. ओके, यहाँ से यहाँ बदल दिया ताकि आपका पॉजिटिव चार्ज यहाँ मिलेगा. सो देखना कि इतना अच्छा नहीं देख रहे हैं. सो मैं और एक ऐसे स्ट्रक्चर, सेम स्ट्रक्चर देना चाहता हूँ. सो ये रीअरेंज करके आपका मिलेगा. एंड अभी Br माइनस ऐड करो, Br माइनस ऐड करो, Br माइनस ऐड करने के बाद क्या होगा? आपका प्रोडक्ट 1 ब्रोमो 1 मिथाइल साइक्लोहेक्सेन is formed. Got it? You don't expect the answer, but this ring expansion takes place. Because of the ring expansion, a secondary carbocation turns to be more stable tertiary carbocation. 5-membered ring is less stable, 6-membered ring is more stable. You just see how effectively we are revising the best of the best examples in our today's class. Everybody take a pen and paper and write along with me. I would be delighted if somebody gives the IUPAC's name in the chat box. It is a live interactive session. Bacho, you all use these lessons and you can do the best. और कुछ है? You can ask any kind of generalized doubts as well. We are going to help you from infinity learn. So you can ask infinity number of doubts as well. Right? Ram? Okay. Now आप देखेंगे हाइड्रेशन ऑफ alkenes. Hydration of alkenes. So hydration of alkene, we have 3 major methods. I just want to give you in a single stretch. Like you see, R CH double bond CH2. There are 3 methods that can be used. So first one is H2SO4 diluted, and the second one is BH3 and THF and H2O2 and OH minus, and the third one is going to be HgOAc twice mercuric acetate and NaBH4 in the alkaline medium. So what is this? You say this is acid catalyzed hydration. And this is hydroboration oxidation. This is popularly known as HBO. Hydroboration oxidation, it is popularly known as HBO. And oxymercuration, demercuration. Oxymercuration, demercuration. There are three methods. This is otherwise called OMDM. OMDM. So in this case, you are going to see the formation of CH3 and RCH and CH3 and OH. You are going to get RCH2, CH2, OH, and here RCH and CH3, OH. क्या फर्क पड़ता है इन लोगों को in these three reactions? Okay, thank you. Who is that? Okay, here carbocation is formed. Rearrangement may takes place. Rearrangement may takes place, and also follows Markovnikov rule. MK stands for Markovnikov rule. Product Markovnikov rule के हिसाब से फॉर्म हो सकते. ये दूसरा का कमेंट क्या होना चाहिए? नो रीअरेंजमेंट बेटा. एंड एंटी मार्कोनिकव एडिशन होगा. एंटी मार्कोनिकव एडिशन होगा. अच्छा बात है. यहां पर जो है सो एक सिंगल स्लाइड आपको पूरा सारे के सारे रिएक्शंस पता होता है. सो कार्बोकैटायन इज नॉट फॉर्म्ड, लेकिन प्रोडक्ट मार्कोनिकव रूल के हिसाब से फॉर्म होगा. लेकिन नो रीअरेंजमेंट. लेकिन नो रीअरेंजमेंट होगा. सो दीज आर द थ्री मेजर पॉइंट्स दैट लेट यू नो द डिफरेंस बिटवीन एसिड कैटलाइज्ड हाइड्रेशन, हाइड्रोबोरेशन ऑक्सीडेशन, ऑक्सीमर्करेशन, डीमर्करेशन. आप क्या करते हैं ना, यू स्टार्ट दिस एसिड कैटलाइज्ड हाइड्रेशन, फर्स्ट रिएक्शन यू विल अंडरस्टैंड, सेकंड रिएक्शन थोड़ा सा मैकेनिज्म बता देगा, सो थर्ड रिएक्शन तक जाएगा. बट द ओवरऑल पिक्चर अबाउट दिस थ्री इफ यू नो, सीधा क्वेश्चन को स्ट्राइक कर सकता है ना, सीधा क्वेश्चन को स्ट्राइक कर सकता है. ठीक है, एनी डाउट? क्लियर? Okay, take a snapshot everybody. 3, 2, 1, click. Now let's talk about hydroxylation. Hydroxylation of alkene. Bayer's reagent. What is Bayer's reagent? Ram, anybody in the live class? You tell me what is a Bayer's reagent. I just directly want to take a cyclohexene as an alkene as an example. This can be treated with cold alkaline KMnO4. It's a good reagent, good oxidizing agent, strong oxidizing agent. You are going to get syn addition. So addition takes place on the same side of the double bond. That is what you say, syn addition. You are going to get OH and OH. Okay, syn addition. The same chemistry obtained OSO4 in the presence of aqueous NaHSO3. It is also a syn addition. So diol, 1,2-diol is formed, that is called glycol. 1,2-diols are called glycols. So if you use a peroxoacid, I mean to say peroxoacetic acid, peroxoformic acid, okay, trichloroperoxoacetic acid, peroxobenzoic acid, metachloroperoxobenzoic acid, MCPBA, you are going to get anti-addition, so that the product, it is stereo selective reaction. So this is a syn addition. And this is your trans addition. Syn addition or trans addition, you also said trans addition is anti-addition. Today we are going to learn, you are learning with me the total alkenes reaction in one shot. No reaction is left spare, right? Very good. And this is called hydroxylation. इसमें और एक चीज़ आपको बताना चाहता हूँ, cold alkaline KMnO4 is otherwise called Bayer's reagent. So the pink color is decolorized so that it is a test for alkene, test for unsaturation. Any carbon to carbon multiple bond can give this Bayer's test. Alkenes gives and alkynes gives. Cyclopropane also gives. That is an exceptional case. Why? Because cyclopropane, due to high ring strain, it is behaving like an alkene. Are you getting or not? Clear? That's perfect. Now let's talk about ozonolysis. Ozonolysis. So what happened? आपका ये वाला आपको पता है KMnO4 in the presence of alkaline medium 25 degrees centigrade में करने दो. We know that just in the previous slide we discussed this. In the previous slide we discussed this. Okay, OH and it is going to be OH, right? Now if you want to say that KMnO4 in the presence of an acid, if we heat it, what happened? Carbon to carbon bond is broken. So what you are going to get, the product is going to be carboxylic group banega. Hexane dioic acid, carboxylic group banega. Understand? You see, all the reagents have been covered. All the reactions has been covered. है ना? Wonderful. बच्चों कुछ डाउट है ना तो आप सीधा आप सेशन में पूछ सकते हैं. अभिनव, राम, Elias, Kanishka. So that temperament you develop it. All the best for your examination. And I want to give you one more ozonolysis reaction. Ozonolysis reaction आपको लग रहा है this is so complicated. I don't want to complicate it. Make it simple. It is an alkene. Okay, let us do ozonolysis. Zinc in the presence of hydrolysis. If zinc is not used, the carbonyl compound that is formed is further oxidized. So let us prefer reductive ozonolysis. So उसमें आता है, don't do anything, break the double bond and place an oxygen R-CHO. Are you getting or not? Are you getting or not? So लगता है आपको CH3, CH2, CH double bond, CH and CH3. So zinc, hydrolysis, O3. So what happened? You just simply break this double bond, make an oxygen. the product is going to be propanaldehyde and ethanol. So उसमें क्या चीज़ मिलेगा? So the products will be given. In the examination you are asked to predict the corresponding alkane. So you can write this alkene from here. कैसे? Simply remove the oxygen, make the double bond. Okay, this is what you can say retro alkene analysis. This ozonolysis reaction is helpful for predicting the position of the double bond. समझ में आ रही क्या? So इसका प्रोडक्ट क्या होगा? CH3 CH2 CH CH2 एंड ओजोनोलाइसिस करो जिंक एंड H2O, क्या मिलेगा? Simply double bond, break it, and you are going to see CH3 and CH2 and CHO and HCHO, formic acid. So उसमें डबल बॉन्ड कहाँ पर है? फर्स्ट पोजीशन में या सेकंड पोजीशन में, ताकि आपको पता चलेगा. एंड यू आर गोइंग टू सी CH3 CH3 डबल बॉन्ड CH and CH3 and O3 zinc and water. So you're going to see a bond is broken here, so that you're going to get branched alkenes will get the ketone bus. Okay, so check the method I have given you. सारे के सारे रिएक्शन एक ही ट्रिक इस्तेमाल करके, ये लाल वाला लाइन जो देखो, that makes you how to break it बस. And organic chemistry, you feel it is so difficult. It is not at all so difficult. It is so easy once you have that command. You please follow our lessons on a regular basis, and you follow this kind of tricks in my class, and you are going to experience the awesome journey with NEET examination. Bachcho, you please like our sessions and subscribe to Infinity Learn NEET channel. And today we discussed alkene preparation and reactions, preparation elimination reactions we have seen, dehydrohalogenation and dehydration and controlled hydrogenation. And in the properties addition reactions, electrophilic addition reactions, we have seen HBr addition Br to CCl4 and Markovnikov rule, anti-Markovnikov peroxide effect. Also we have seen hydroxylation, also we have seen, and this ozonolysis reaction. और क्या चाहिए इसको? We are doing the best out of these reactions. So in the Telegram channel you please join us, so that सारे के सारे notes आपको PDF format पे free of cost को मिलेगा, and you just revise it and make a cheat sheet of it. Okay, thank you very much. We are done for today. We'll meet with more stuff in next class. Thank you very much.